And we're back.
Welcome back.
Nice. All right. Oh yeah, group collaboration directions. I see it now. Don't know how I missed that.
Wait, what?
Just waiting on Dorothy.
Yeah, she's fine.
There she is. Hey, Dorothy.
All right.
You ready to knock out chapter 17?
Yep. I'm ready in the quiz.
Okay, me too.
Yeah, me too. I'm ready to go.
Yep, same.
All right, well, you are required to work. Oh, forget that. The symbol for the true population proportion is which of the following?
That's C, right?
Yeah, I think it's C.
Mhm.
B or C?
C.
Okay. Sorry, I'm hearing when you guys are saying C.
Yeah, the last one.
Is that
So
true?
I think it's true, personally,
Yeah.
because you can find the z-score with those numbers,
Mhm.
which would also allow you to do that. So. Cool.
Isn't there something where it has to be larger than 10? That's the calculation.
Yeah.
10.
So we multiply that. Oh, I'm trying to remember.
N times P at. So 100 times 0.10 gives us 10. So it needs to be greater than or equal to 10. So yeah. Good.
So 5 would be true as well.
Wait, so you just did 0.25 times 0.1?
No, 100
wait.
times 0.1.
Yeah,
Okay.
100 times 0.1. Yeah.
Okay.
And
So that comes to be 10.
so the requirements for conducting a hypothesis test are satisfied. True. Yep, for number 5.
All right. Find P, the point estimate of the proportion of first-degree murder defendants who were found guilty in this state. Okay. A study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty.
So just do 45 divided by 60.
Yeah, I think that's what it is.
0.75.
Yep, 0.75. Oh, wait, it says to do to 3, though.
570.
750.
All right.
Throw us off with these questions, dang it.
Yeah, they're not like the homework questions.
Yeah.
Yeah.
I feel like they never really quite like them.
So create a 95% confidence interval for the true population of first-degree murder trials in the state where the verdict is guilty. Input your answers for the margin of error, lower bound and upper bound. The margin of error for this. Couldn't we just put that into the applet thingy?
I think so.
Oh, I need to pull that up.
Our sample, random sample is 60.
This is doing for 2 samples though, and I only get 1.
I don't see how we could put that in the applet. I thought that we would have to do the like p hat plus or minus the z-score.
Oh yeah, because the z-score would be 1 point, what is that?
Yeah.
6?
Yeah. Let me put it in again just to make sure.
I'm gonna read through that in my notes.
1.645. And then we multiply that by the square root of p hat. Square root of 0.75. 1 minus just p. P is 60, right?
Yes.
And then 45 would be n.
No, the other way around. I'm sorry.
Oh, okay.
60 is N.
Okay. I have the hardest time putting these equations into my calculator.
Mm-hmm. Okay, I got 1.311 or 12 for the z-score. Does that sound right?
Yep, tell you. I'm still doing it.
Wouldn't the z-score just be 1.96? Because it's a 95% confidence interval?
Yeah.
So we're looking for the margin of error.
Yeah. I got 0.054.
Oh my gosh, you're so right about the z-score thing. Wouldn't it?
Yeah.
Oh, I feel so dumb.
Me too. I'm right there with you, James. All right, so
That was a lot of wasted effort.
we're doing the p hat plus or minus the z-score and then the square root equation, right? Then
Yeah.
Mm-hmm.
plus or minus
Wait, what?
1.96.
So on number 2 in your preparation assignment, we're using that equation.
Yeah, so it's the z-score times p hat times the 1 minus p divided by n. That's all square rooted.
Mm-hmm. Only you also have p hat plus or minus.
I think that's for the lower and upper bounds. For the margin of error, we just need the z.
Oh, yeah. Okay.
Yeah, I did that same thing, and I'm like, what the heck? This doesn't seem right.
Wait, did you say p hat though? What?
Yeah, so the only thing that changes is in the equation is the p, so it's p hat times 1 minus p. Before it was just p times 1 minus p.
Oh, okay. I see what I'm doing wrong. Okay. Yep. Okay. We're good. We're good. My bad.
So how do we get the margin of error?
The margin of error is the z-score. So it's everything minus. Okay, I need to explain this correctly. I wish I could just show you guys this. I'll flip on my video if you want to go there really quick.
Yeah, you can share your screen
Yeah, share your screen.
if you're doing it in Excel or something. I don't know.
Oh, I'm not. I'm doing it by hand.
Oh, well, put it up to your camera, your piece of paper.
Yeah. Okay, if you guys want to look here, I'll write the equation out again. So,
So did you get negative 2.195?
I got 0.0536.
Okay.
I could be wrong though. I mean, I was wrong not too long
Oh,
ago.
I didn't take a square root. Never mind.
I did that same thing.
So
I don't remember seeing a formula at all to get the margin of error.
Can you see this one in my camera?
Okay. Oh, it went away. Okay, there.
So z times, sorry, I should have written that bigger.
You're good.
Backwards, I think.
No, it's good.
So p hat is 0.75.
0.75.
Can you put that back up again real quick? Sorry, I'm
Yeah.
slow.
Sorry.
The point estimate, didn't we decide that was 0.750?
Square root p hat 1 minus p. Okay. All right, got it. Thank you.
So the p hat in this one is given to us.
So
you go-
p hat,
If you scroll up, it shows. Oh wait, crap! I might have done the wrong
Calculated
one.
that the 0.750 was the p hat, right?
yeah.
Dang, I did it wrong. But yes, yeah, I just put the wrong p hat in.
Okay, so square root of, so it'd be inside the square root, 0.75 times 1 minus 45 over 60. Thing is, that gives me error, like my calculator won't do it, even if I break it down.
Okay, so let's do. I just got to run through this again. I just lost my whole train of thought. Sorry.
You're
Is-
fine.
Is the p hat and the p the same or no?
No, they're different numbers.
Okay.
So p. That's why I'm thinking.
What is P again? Is that the 45 or the 60?
That would be the
P is n. I know that for sure.
Yeah, 45 is p. Okay, so that was
Okay.
the wrong numbers. That's why I got that number.
Heuristic. That's right. P is the
So when I put that in the calculator, I get negative 0.55, and then I can't take the square root of that.
Let me. I'll go here. Sorry, I'm trying to.
You're fine. Take your time.
I did it for the last numbers.
I think the p hat and the p are the same in this.
How do you figure that?
Well, just
That would make a lot more sense. It just seems weird.
characteristic.
It seems really weird to have P hat be 0.75 and then the population be 45.
Trying to find where I wrote it down. I don't know. I'm confusing myself.
I know, I'm like totally walking backwards now.
Yeah, I'm just trying to read through chapter 17 again real quick.
So mine won't even let me do a negative for some reason, but it's giving me 0.7416 times that by.
Now I got 0.133 or 0.132. And that's for the upper bound.
Did you find the margin of error already though?
No, I just realized that I did another step that I wasn't supposed to.
That's
But
all right.
it would be the upper bound, I think.
So based on the calculation that you gave us, Josh, I got negative 1.069 for the margin of error.
You got negative, what'd you say?
1.069.
That's funny because I've run this calculation like 3 times and it gives me a different answer and none of them were those.
I'd have forgotten to do the square root. Let me do that again. Oh.
So wait, are we using 0.75 for both the P and the P hat?
I wasn't at the moment. I was doing 45 for P.
Hmm.
I almost wonder if that P hat's not supposed to be there. Oh boy.
So we're doing margin of error, right?
Yeah.
So I
Right.
just
Yes.
the chapter. I do not like this is the formula for the margin of error is M, so margin of error equals Z score times square root of P, not P hat, parentheses 1 minus P parentheses over N.
See, and that would make more sense because P hat like makes it all screwy.
It's
So
the same thing as the
45.
standard deviation,
Yeah.
Z score in front of it.
So if you guys look down to number 7, C, I think it's C, they have the equation and they use the same number for P and P hat.
Where at you said?
7C on the preparation assignment.
Oh, okay, I'd have to whip that back up, so I'll trust you on that one.
But yeah, so they use P hat for both of them.
So the 0.75 then? Not,
Yeah.
They use the P hat for both of them as far as for the upper and lower bound, is what you're saying?
No, for like inside the square root in the numerator.
Oh, they use P hat for both.
Mm-hmm.
So it'd be like P
Because
hat times 1 minus P hat.
yeah.
Weird. All right. That would make more sense though.
Yeah, I don't know. I'm just trying new things. And that's what it has right there. And I checked the answer.
Well, let's do it that way according to the homework, and then we'll check it. And if it's wrong, we'll try a different way.
yeah, so I got 0.167 for the margin of error then. Anybody else get that?
I got 0.0919.
We all get the different score.
Oh my gosh.
Minus 0.75, you get 0.25 times 0.75 equals 0.1875 divided by 60.
It's 0.003125, right?
And we do the square root of that. And then multiply by the C score of 1.96. 0.10956.
I'm just gonna double check it in mine. Sorry, I'm a little slow.
Yes.
I'm like so lost right now.
So we've determined that the P hat and the P James are both 0.75. So we're still on the question number 7, trying to figure out the margin of error. Using
Yeah, I
P times this.
that much. I'm still just getting random numbers.
I know. It's
Are you multiplying this by 1.645?
No, it'd be by 1.96 because that's 95%.
Yeah.
Really?
Yeah.
Yeah, it had the 90.
I'm pretty sure 95% is 1.645.
And in my notes, it says 1.645 is for 90, and then 95 is 1.96.
Yeah, 95 is
Or are we-
1.96.
So we're doing 95.
Yeah.
Okay, so when I put that in the applet, it comes to 1.645.
Really?
No, just kidding. I swear it just changed.
I know. That thing can be tricky. Yeah,
Oh my gosh.
I know.
So sorry.
No,
It happens.
All right.
that applet is so buggy.
Mhm.
All right. 0.109 is what I have.
Yeah.
I got.
So would that be
All right.
0.110?
Oh,
What
right.
was-
Yeah, I think you're right. 0.110 then would be, should
Mhm.
round that up.
All right, it's 0.110.
Yeah, for number 7.
Real
And
quick.
then, now we plus or
Never got
minus.
that number. Can we just
The
run
P-
through the formula real quick again to make sure I didn't write it down wrong or do anything stupid?
Yeah, so 1.96. Or do you want just the formula or do you want what we put in?
Just give me the formula because I think I wrote down wrong and that's why I was getting stuff completely different.
Okay, so z-score times the square root of p hat.
Not p hat, just p, right?
Oh,
That we decided. It's just p.
no, because
No.
isn't 0.75 our p hat?
Yes, it's p hat for both of them inside that equation.
Okay.
Yeah.
Right, so p hat, parentheses, 1
Parentheses,
p hat
yeah, 1 minus p hat,
over
close
n.
parenthesis, over n, and that's it. Just make
Okay,
sure
I
that
remember.
you've got a square root in there.
Yeah, I wrote it down right. I'm just dumb, I guess.
No, you're fine.
Very
This
confusing.
is tricky.
So now we just take that 0.110 and plus add and minus it to the 0.750.
Yeah.
So I got 0.64 for an 8. Like I
Let's
said,
see. So we do 0.110 plus 0.75.
Yeah.
and then you also do minus.
Yeah.
But it's the other way around.
Upper.
Yeah. So negative 0.64.
I think it's just 0.64 because you would do 0.75 minus
Right.
0.1.
I got-
Oh.
Yeah, not the other way around.
0.64 and 0.86.
Yeah, but we want to make sure we put a 0 there because it says 3
I did.
decimals,
Yeah.
just so that we're not getting.
Just to be on the safe side. All right. You okay to move on to number 10?
Yep.
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 You increase the sample size from 60 to 80. What do you expect to happen to the width of the confidence interval?
It'll decrease.
Yeah.
Smaller.
To conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose p equals 1/2. What is the smallest n can be and both requirements still be met?
How did we do this again?
I'm trying to remember.
So we try to, it has to meet 10.
Oh yeah, so it'd be
So-
20, right?
20. Yeah.
Yeah.
It's 10 divided by 0.5, right?
Yeah.
Okay, yeah, 20, right?
hmm
Right.
Mm-hmm. So this next one would be 100.
Yeah, that's what I would assume.
All right, 13. For the water quality study and the reading, about 60% of the macroinvertebrate water quality indicators have historically been associated with good health. Research suspects that water quality in the area is decreased. They conduct a hypothesis test using significance level A equals 0.05 with the following hypotheses. They collect new data, and this time n equals 80 and x equals 38. Indicate good health. Conditions for conducting a hypothesis test are satisfied. True or false?
So we just do x divided by 80, right? And that'll give us our p hat, and then we can. Oh wait, this is p, isn't it?
Are we saying it's true then on question 30?
Yeah, I think it's true personally. Because once we find the p hat, we can do everything else.
Yeah.
Okay.
So
So then
that is 30 divided by 80, right?
Yeah.
yeah, so 0.475.
Yeah, that's what I got.
Yeah, me too. And then we need to find the z-score, right? Or what's the test statistic in this? Is this the t-score or is this?
The Z.
I think in this we just need to put in,
I think we can use, yeah, the Excel file for this maybe.
but why does it give us two values? That's what I don't get.
What do you mean?
So it has, so are you in that document?
Yeah.
So it says X1 and N1 and then X2 and N2. That's weird.
Oh, you know what? You need to click on the bottom tab so it says one proportion.
Ah, that's why. Aha, okay. Makes sense.
I think it automatically opens to that two proportions tab because I had to change over.
So we're trying to see if it's less than 0.6, right?
Yep.
We'd have to change that to less than and to 0.6, right?
Yep.
Nice. Our p-hat was correct. That's good. So our test statistic would be negative 2.282.
That's what I got. The p-value 0.011.
Yep.
Hmm.
What is the decision for this test?
So we reject the null hypothesis, right? Because p is less than a.
Yep.
And then there's sufficient evidence to conclude that water quality in the area has decreased, right?
Yep. D.
The
All
last.
right.
I'll submit.
All right.
You guys kind of sped through that. What was 15 and 16, just to double check?
15 was negative 2.282.
Cool.
And then 16 was 0.011.
All right, cool.
Hey guys, we got 100%.
Awesome.
By some miracle.
As long as we all type the same values in, we'll be good.
You want me to go over it with you guys? Just double check your answers.
What was question 5? For some reason, I forgot to answer that one when I tried to submit it. Was that
5 is true.
Okay, that's what I thought.
And once we finally found out what 7 was, that was because that was like a half hour on that stupid
Yeah.
problem.
I'm pretty sure we did the
Fine.
first question or the first quiz faster than we did question 7.
Yeah.
Which is actually very simple. That's what's funny about it. Which is a good thing. All right. Well, thank you.
All right.
What do you guys want to do about the other assignments due the end of this week?
So I'm looking at it right now because I don't even know what it is.
Yeah, why don't you guys take a look at it and we can kind of email ideas of what we want to do.
Yeah.
Maybe we can
The
even,
only day I could meet this week would be Thursday night.
Let's do
Thursday.
Thursday night.
Yeah, how about we just do that, even if it takes 10 minutes, just to
yeah,
make
text
sure.
them. Okay.
Yeah.
Let's,
All right.
does that work for you, James?
I think so. I have a meeting that day for work. I gotta figure out what time it is, but I
Okay.
can get back on that.
All right.
And what was 8 and 9? Because I got those wrong.
8 was 0.64 and 9 is 0.86.
Okay, cool. I'm dumb. I just swapped them accidentally.
Oh, that happens.
All right, cool.
Okay, well, let us know. We'll plan on meeting Thursday unless you tell us for some reason you can't, James. We can try
I can.
or email in the meantime.
I'm pretty sure I can skip the meeting if I need to, but we'll see.
Okay, just let us know
All right.
then.
Talk to you
Okay,
guys later.
have a good night, guys.
Yeah, we'll see ya. Bye.
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 That is